Good morning, everyone. I hope all of you are in your good health. So, let's begin our next topic of the chapter number 2, chemistry, that is acids, bases, and salts. So far, we have read about what are acids and what are bases and how do they react with the other compounds such as metals and the other things. And we have also discussed about the pH value of the acids and bases and what are their uses. So today we're going to start our next topic, that is salts. So salts are the compounds which are formed when acids and bases react together, and this new compound is almost neutral because when acids are corrosive and bases are caustic. So when both of them react, they undergo a neutralization reaction. So the compound which is formed out of that reaction is salt, which is also a neutral compound. Yes, it can also happen. A salt can be towards an acidic or towards a basic, or we also term salt as acidic salts or basic salts. So when a very highly reactive acids react with a weak base, it forms a acidic salt, or when a highly reactive base reacts with weak acids, it forms a basic salt. So this is a common thing. We have in your NCERT book, you are having different names of salt which we're gonna discuss here. So here's a definition of salt, that is a compound formed from an acid by the replacement of the hydrogen in the acid by a metal. So acids are called as acids because they have hydrogen ion. Along with the hydrogen ion, they have a non-metal in them. So whenever the hydrogen of the acids like HCl, so when this H is replaced by a metal, it is called as acids. Like if it's HCl plus NaOH, so the H is replaced by Na, that is sodium, so it is formed at NaCl, so that is a salt, it is sodium chloride. So basically the definition of salt is a compound formed from an acid by the replacement of the hydrogen in the acid by a metal. So here in your NCERT book, there is an activity in which there are names of different salts, that is potassium sulfate. So potassium sulfate is K2SO4. This is potassium sulfate because there's a question that you have to write the chemical formula. So I'm just helping you out. So in this salt, there can be a base and acid because salt is only formed when acids react with base. So this salt have acid and base. So the base is KOH and the acid is H2SO4 because this is a very highly reactive metal. So this is a very high base or a reactive base, and this is a almost not very weak acid, but the salt which is formed, because this is a very strong base and this is a strong acid, so the salt form will be neutral. And then it's sodium sulfate, so it is Na2SO4, and here the base is NaOH and the acid is again H2SO4. The next one is calcium sulfate. You all know CaSO4. I hope you will know that the base is CaOH whole twice and the acid is again H2SO4, same it is. Then the next one is sodium nitrate, which is it is NaNO3. NaNO3, sodium nitrate. So the base will be NaOH and the acid will be HNO3. So next is sodium carbonate, which is Na2CO3. So in this again the base will be NaH and the acid will be H2CO3, and which is carbonic acid. Next is ammonium chloride. So ammonium chloride is NH4Cl, ammonium chloride, and here the base is NH4OH, it is ammonium hydroxide, and the acid is HCl. So these are the few names of the salts, these, and the bases and the acids. So when this base react with this acids, this salt is formed. Okay, so you have to identify the acids and bases from which the above salt have obtained. So I've already done this for you. And then the next is, salts have the positive or negative radicals are said to belong to a family. For example, NaCl and Na2SO4 belongs to the family of sodium salts. So here, if you can see here, so wherever the first name is, so this is the potassium salt, this is the sodium salt, this is the calcium salt, again sodium salt and ammonium salt. Okay, so they are named by this. But if the last is also same, so this is SO4, 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 so they can also be called as sulfate salts. Okay, so they are named like this. Now this is done. After this, the chemicals from the common salt. Now common salt is a salt which you all know that NaCl is termed as common salt. NaCl, which is a very common salt, because salt can be all these are salt. So whenever we say salt, it does not means that NaCl, but the common salt which we call in our common language, because this is called as sodium chloride, which is a chemical name, but in our daily language we call it a common salt because we also consume it in our diet. So actually this common salt is made from the sea, or it is also obtained from the mountains, because where they were sea once, so it has been almost dried up and it has built into the mountain. So we can get the salt, this NaCl, from the large crystals from the mountain in a brown color, red color, and different colors. Or we can also dry up the sea water, and we can dry up in the sea pans, then we can also get this salt. But we can also make many other compounds from this common salt. So here in today's lecture we will be reading about the things which we can form by this common salt. So here we go is that, first of all, from this common salt we can make many different compounds or many different important things which are very useful to us. So first comes in this is, we can also make sodium hydroxide out of this. I hope you remember what is sodium hydroxide. This is NaOH. So whenever we have to make this NaOH, because it is a base, and if you want to make a base, we can also make this by the help of a process which is called as Chlor-Alkali process. So in this we're gonna make sodium chloride, we're gonna make sodium hydroxide from the sodium chloride. So in this what we'll do is that we will take a container. Here in your book it's a diagram given. So we're gonna take a container, or actually it's not a container, but the process will be called as electrolysis. In this we will have some water and we will make it an electrolyte. It will be a conducting solution, and then we will be having two strips which is called as anode and cathode. The positive one electrode is called as anode and the negative electrode is called as cathode. So same in the process, we will have this container filled of NaCl solution, which we also call as a brine solution, BRINE, brine solution. So actually this is called as Chlor-Alkali process. Chlor-Alkali process, this name is given to this process because in this process or in this procedure we get three things, which is chlorine, okay, as a product. We will get alkali, which is NaOH, okay, because bases which dissolves in water are called as alkali. So NaOH dissolves in water, that's why it is called as alkali. So we will get chlorine and alkali, that is why it is called as Chlor-Alkali process. Along with this we will also get hydrogen gas. So when the electricity passes in the solution, from this we're gonna also have a battery, obviously. So when this is a brine solution, which is a solution of, this is a concentrated solution of NaCl. So a lot of NaCl, that is sodium chloride, is dissolved in the water. So on passing the electric current, the NaCl will decompose and it will break down into simpler form, that is Na plus and Cl. Okay, and here in the water, because NaCl is mixed in the water, so here also there will be H plus ion and hydroxide ion. Okay, clear. So this Na will get mixed with this OH, so it will be NaOH, fine, and this hydrogen gas and chlorine gas, hydrogen gas and chlorine gas will be released. So this will be the product. Okay, that means NaCl plus H2O will get NaOH, H2, this is nothing, okay, H2 gas and chlorine gas. So this is the basic reaction which undergoes in this process, which is called as chlor-alkali process. Okay, so here we will get three different things. First we will get chlorine, which is chlor, and then alkali, which is NaOH. So our target was to make sodium hydroxide, that is sodium chloride. So here's the reaction also, that we're gonna take NaCl and water, and then we're gonna get NaOH, chlorine gas and hydrogen gas. So all these three products have their different properties and their uses. Like here it's written, this chlorine gas which is obtained from the anode section. Okay, so here is an important thing which you have to remember always, that chlorine gas is obtained from the anode and the hydrogen gas is obtained from the cathode. This question is asked a lot of time, that where do we get the hydrogen gas from? So we get the hydrogen gas from the cathode and chlorine gas from the anode, and the sodium hydroxide is formed near the cathode. It is obtained from this compartment near to the cathode. Okay, so it will be a solution form of a sodium hydroxide. So this gas is used in the water treatment. It is also used in swimming pool. It is used as disinfectant, and it is also used as chlorofluorocarbons, and it is also used in pesticides. And then the use of hydrogen gas, it is used as fuel, margarine, ammonia for fertilizers. It is used to make ammonia for fertilizers. And at last, the use of NaOH, it is used as degreasing metals, to degrease the metals. When we grease the metals, to remove the grease from the metals. It is used in the manufacture of soaps and detergent. It is also used in paper making and artificial fibers. So I have written for you this, that sodium hydroxide is produced by the electrolysis of the concentrated aqueous solution of the sodium chloride, which is called as brine. The simple reaction is 2 NaCl reacts with 2 H2O. Here all this is done due to balance the reaction. So we're gonna get 2 NaOH, Cl2 and H2. This is the gas. So these are the things which are very important, that chlorine gas is obtained from the anode and hydrogen gas is produced at the cathode, and NaOH is formed near the cathode, and the process is called as chlor-alkali process. And the uses of NaOH are, they are used for making soaps and detergent, they are used for making textile fibers, and they are also used in the purifying bauxite ore to get the aluminium metal from it. Okay, so this was a sodium hydroxide formation from this. Now next is we're gonna do is that the here you are having bleaching powder, which I will be taking this topic in the next lecture. So first we're gonna try this baking soda, which is also called as sodium hydrogen carbonate. So here I will also be telling you with the help of book and with the notes also. So sodium hydrogen carbonate, which is also called as baking soda. You can also write this sodium bicarbonate. Okay, and the formula is NaHCO3, sodium hydrogen carbonate. I hope you know this because we have read in class 9th also. So to make sodium hydroxide, we also need again sodium chloride. So we need common salt to make this sodium hydrogen carbonate. Okay, so along with this we will need some ammonia. So when NaCl will react with ammonia along with water and CO2, because here in the formula it's CO2, so we will also require CO2 gas. So sodium chloride plus ammonia plus water plus CO2 will get sodium hydrogen carbonate or sodium bicarbonate. It is NaHCO3. Along with this we will also get another thing, which is ammonium chloride, NH4Cl. So this is the product which we are gonna get as a byproduct. want to make this, and we will get this as a byproduct. So for this we need NaCl plus ammonia NH3 plus H2O plus CO3. We will get NaHCO3 and this ammonium chloride. So now this sodium carbonate is sparingly soluble in water. Sparingly means it is not completely soluble in the water. It's dissolves slowly but not completely. So it just remains as the solid precipitates in the water, and we are having many uses of this. So the properties of NaHCO3, that is, it is a mild. It is very mild and it is non-corrosive because it's a base, or we can also call it a salt. So generally it's a base, so it is a very non-corrosive base. That is why we consume it also. The common name of this is baking soda, and we also consume it, we also use it in a lot of baking things, in the bakery products, in the baking process. So it is safe for us to consume, and the pH value of this is between 8 to 9 or close to 9.4, or from 8 to 9 approximately. And it is a very mild alkaline. So it is alkaline, so, and very mild alkaline. It is not at all caustic in nature, and they are in the color of white crystals. So they do not dissolve properly in the water. So these are the property. Now the most important property of this is action of heat. So when we will heat this, what will happen? So when we heat this, the hydrogen from this just removes from this, okay, NaHCO3. So it will become sodium carbonate. Okay, so after heating this NaHCO3, it will become sodium carbonate, and then CO2 gas will be released and water will be released. So sodium carbonate is the washing soda. So we don't heat it directly, we also use some salts or some acids in it, so that whenever in the baking we don't use sodium, this baking soda alone. Either we use baking powder, because in the baking powder there are some tartaric acids. So when it is like, if we are using it in our any recipe and we are using baking soda, so you would have also heard or seen that the cooks and all, they just add baking powder also along with baking soda, because this baking soda has some acids in it. Baking powder, sorry, has some acid in it, so it does not allow it to form sodium carbonate, and it forms a basic salt which enhances the taste of the food. So on the action of heat, so on heating this, we will get sodium carbonate, and this hydrogen will be released in the form of water. So that is why here is 2. Now the uses, it is used as an antacids to remove acidity, because we also you have seen people, there are a lot of ads which comes in the TV that just have ENO, so to get rid of the acidity. So ENO is the same thing which have this baking soda in it. It is also this is also used as a fire extinguisher. So this can be easily made by, you can make a flask, you can keep a bottle, and in the bottle you can have a solution of this sodium hydrogen carbonate in it, and in that we will add slightly, you're gonna just pour this sulfuric acid. So as soon as the baking soda reacts with the acid, there will be a effervescence of CO2 gas, and CO2 gas, we know that it is a non-combustible gas, so it will just cut the supply of oxygen, and it can work as a fire extinguisher. So after this we gonna study this sodium carbonate. So the last one is sodium carbonate, which is here. Okay, then this is sodium carbonate. Now this is a little more from that. This is also an easy. So all these things which I am telling you today they are very important. You have to learn how to prepare sodium hydroxide, you have to learn how to prepare sodium hydrogen carbonate, you have to learn how to make sodium carbonate, and what are the things which are called as all ifs and buts, all why it is called so like that. So sodium carbonate decahydrate. Decahydrate is the word which is added. So this is because it is water of crystallization. So water of crystallization I will be teaching you in the next lecture, but for today I just want to tell you that whenever there is a a crystal of, whenever there is a molecule of water present in a crystal of salt, so that is called as the water of crystallization. So here in this, it is Na2CO3, which you have learned in the previous classes, but I have added here 10H2O. Okay, so this 10H2O is the water of crystallization. So this 10 molecules of water makes it deca. Deca stands for 10 and hydrate means water. So these are the hydrated salts which you will touch. They will not wet, but in their crystal there is the definite a molecule of water in it. So if there is not this 10 molecules of water, it will be a dry soda, or it is called as soda ash, which is a caustic soda which do not possess the property of sodium carbonate decahydrate, and it is not called as washing soda. It is called as caustic soda or soda ash. So this washing soda can only behave as washing soda when there are 10 molecules of water in it. That is why the name of this is sodium carbonate decahydrate. So to make this, again we will repeat the same process, that is NaCl plus NH3 plus H2O plus U2. If you remember, this is the same reaction which we did in the formation of the baking soda. So here we are making baking soda again. So this is baking soda, which is sodium hydrogen carbonate, and this is ammonium chloride. So first reaction is same. So to make washing soda, first we will make baking soda. Now we will heat this, and on heating this hydrogen is removed. This also we have read. So it will be Na2CO3, that is, it is sodium carbonate, but still it's not decahydrate. So here we will add 10 molecules of water. So we will get this sodium carbonate decahydrate. So this is a simple thing. Now it has many uses. So uses of washing soda, okay, you have been given in your book. So they are used in the glass, soap and paper industries. It is used in the manufacturing of sodium compounds such as borax, which is used in washing powder, and they can also be used as a cleaning agent or domestic purpose. That means they are used in detergents and all the soaps, and they are also used in removing the hardness of water. So these are the uses of sodium carbonate decahydrate. So today we have learned three things, that is sodium hydroxide, how to make this, then baking soda, which is called as sodium hydrogen carbonate, and then washing soda. So bleaching powder we will be doing in the next lecture. Till then, please do all the question answers and go through the videos which we make, and please study hard and stay safe. Thank you.